Hey everybody, welcome to graphing, writing, and showing inequalities. So this first video is just where we're going to kind of remind you stuff. This is stuff you should have known from the 7th or 8th grade or even the 6th grade, but we kind of want to start from the same ground here. If you get this, you don't have to watch this. You can just do the problems underneath it. If you can't, I'm here to help. So here we go. It says today's I can statement says I can solve linear inequalities, equations and inequalities in one variable. So you have to be able to solve an inequality. That's your goal. And then I can graph an inequality. And we're going to talk about how to graph an inequality. And so first of all, what is an inequality? An inequality is a statement that two quantities are not equal. So for instance, in the past we've done stuff like 5 equals 5. That is an equality, right? This side is the same as that. An inequality would be if I had something like 3 and 7. Well, which one is bigger? Well, 3 or 7. Well, 7's bigger, so I would say that 3 is less than 7. So an inequality is when we're saying they're not the same. However, the rules for them are basically the same. We can still do the same things. We're going to talk about that later. Let's just talk about what an inequality looks like. So you may have remembered seeing these things. We usually read from left to right, and so I read from left to right. This is what a less than sign usually looks like. This is the sign for a greater sign, because I read from left to right, and this is the greater sign. This is less than or equal to. That's a situation where you could have the amount. So if I said to you, I have $5 or less, I could have $5, but I might have less than $5, but I would not have more than $5. And then this is the sign for greater than or equal to. And then on a graph, when we do that, we use open circles for less than or greater than, and we do solid circles for less than or equal to, or greater than or equal to. And the reason why I do solid circles is we're saying on these that this is included. So in other words, if I want to say it's 2 or greater, well, here's 2. It could be 2 or greater, so I'm going to the right because that's greater. If I said greater than 2, that's a circle around because the 2 isn't included. That's not my answer. It's greater than 2. It's any number that is greater than 2. And I always fill in my arrows at the end because that tells people, even though the graph doesn't go on forever, that my line actually does. So solutions to an inequality are any value that makes the inequality true. So this is where it gets kind of tricky. If I say a number is like x is greater than 2, there's more than one answer. There's not just one answer. A number is greater than 2. Well, Ms. Garcia, what are some answers bigger than 2? What are some possibilities?
3.
3. That's an answer. What else could I have?
50.
50. What else could I have?
1 billion.
Woo! 1 billion. And I can keep going. But I could also go 2.1. That's bigger than 2. I could go 2.0001. Isn't that bigger than 2? Anything bigger than 2. So the problem with inequalities is when we did equations, we could find just an answer. X equals 2. That's it. X equals 2. But when I say x is greater than 2, I have infinite answers. And that is why we have to graph things. So I say, oh, x is greater than 2. So I say, can x equal 2? No, because there's no line there. So I'm saying x is greater than 2. So 2 is not included, but anything bigger than that is going to include. So the reason why we graph inequalities is because this is the only way that we can show all the possible answers. I can get 3 as an answer for a billion, 2.1, 2.001. And then a little thing I always do is the way I kind of remember in my mind is I say less is left. It kind of rolls off the tongue. Less is left. When I say right is greater, I'm talking about like Tony the Tiger cereal, you know. It sounds stupid. But so, yeah, whatever. Right is greater. That sucks. Just remember left is less, and anything else is greater. Left is less. Anything else is greater. All right. So Mrs. Garcia is going to come in here and break it down for you a little bit more and tell you what we're doing. Go ahead, Ms. Garcia.
Okay, so this one is mostly about how to read these different ones, especially when the equality doesn't look like the way Mr. Craig was drawing it on the last slide. So what we want to look at is what is looking at the variable. This is going to sound a little silly, but we've got a mouse and we've got a gator. And you know, you got your little mouse like this, and you got its nose and some whiskers and an ear, little eye so it can see, and then you've got the gator. Big old mouth with the eye back here and a big mouth full of teeth.
That's a scary gator.
Isn't it though? So we're gonna look at which one of these two is looking at the variable. So this first one, we have n on this side. So what is looking at this n? What is looking at this variable? Well, it certainly looks like a mouse to me, just like this one right here. It got a little ear, got a little eye, some whiskers. A mouse is looking at this n. Now, a mouse is smaller than a gator. I don't know about you, but whenever I picture a mouse, I picture this little tiny little fluffy thing, and a gator is basically a dinosaur that lives in the swamp. So, this one, this is telling us that n is going to be the smaller of these two sides, so n, we could say, is less than 5, and you know what? That means we could also rewrite this. Because like Mr. Craig said on the last slide, this is the symbol that technically reads as less than. But either way, we know that n is going to be the smaller one because the mouse is looking at it. And look, even when we flip it, the mouse is still looking at the variable. Same side, or same deal.
So what are the values for n then, Ms. Garcia?
Well, Mr. Craig, what is something that is smaller than 5? Or, yeah.
Negative a billion!
Negative, oh, you're gonna make me write a negative a
No,
billion,
negative
aren't you?
n,
This is
negative
payback. Okay, so negative 1 billion. There, that looks like a G, but that's okay. Very nice. All right, so what about this one right here? Well, this one, the sign is looking a little bit different from the last one. We need to look at what is focusing on this X. What is looking at our variable? Well, that certainly looks like a gator with a mouth full of teeth to me. So that means, since gator is much bigger than a mouse, hopefully, the X here is going to be a bigger number than the 4 on the other side. So, Mr. Craig, what is an example of a number that is greater than 4?
4.05.
Ooh, you're getting technical here, but you know what? Yes, that is true. 4.05, and we still got our little gator, little tiny gator this time. 4.05 is going to be bigger than the 4, so that checks out to me. And if you really wanted to rewrite it so the X was on the other side, remember the gator still has to look at the X in order for this to be the exact same thing.
So he moves with the variable?
He's always going to be looking at the variable. The mouse and the gator, the focus is always on the variable. They're always looking at the variable. So, this one down here. Oh, we've got this little line this time. Don't forget that one. So, we can still look at whether or not this is, or whether this is a mouse or a gator. This one, focusing on the Y, what is looking at the Y? Well, that certainly looks like a little mouse to me. You got the little ears, some whiskers, and a little eye there. Yeah, that looks enough like a mouse, I'd say.
It's a mouse on a plate.
A mouse on... That's a little sad. It's a mouse on a plate. It's Remy, there you go. He's cooking, apparently.
He's cooking.
So we've got our Y is our focus. A mouse is looking at it, which means our Y is going to be the smaller of these two numbers. Now, careful here. This is a negative number. So, Mr. Craig, what is a number that is smaller than a negative 1?
Oh yeah, because
negative 2.
The bigger the negative, the smaller it is. So I will go with negative 7.
Negative 7, very good. Do not fall in the trap of saying that negative 1 is the smaller number. Because remember, negatives work in opposites here. So negative 7, yes, I agree. So again, still got our little mouse here. Our mouse is looking at where the variable used to be. So yes, I absolutely agree with this. Very good. So, all right, so now we're actually looking at graphing these different inequalities. So we've got our X, and what's looking at it? Well, it looks like a little gator to me is looking at it.
Big gator.
A big gator, you're right. So big gator is looking at this X, which means X is going to be the bigger of the two. So we're starting with the 5. So let's put the 5 here in the middle. Well, what is something that's on either side of this 5? Well, we've got a 6 and we've got a 4. Let's go with some obvious answers. 1 bigger and 1 smaller. So I'm going to circle the number that I started with, that 5. Now I gotta ask, well, do we fill in this circle? Well, no, because this one doesn't have a line under it. It means it's not included. It just starts at 5. Now, X has the gator looking at it, which means X is going to be bigger. So we're getting filled in this direction. There we go. Which means anything that's bigger than that 5 is going to be an answer for this inequality. So what about this one? Now we've got a decimal. First of all, we are starting at this negative 4.2, and I'm going to go ahead and write that so I know exactly where I'm starting. Now, what is looking at the variable? Well, this time X is over here, and I've got this little mouse looking at the variable, which means I know that my variable is going to be the smaller one. So, starting from the negative 4.2, let's go ahead and build a little tiny number line here. This one is a little less obvious, and it doesn't really matter what increments or what numbers you pick on either side, so long as it's the same distance away. So for example, if you picked a negative 5 over here and a negative 4, this one doesn't make a ton of sense because negative 4.2 is not in the middle of negative 5 and negative 4. But say I wanted to use, let's pick negative 4. We wouldn't use a negative 5 here. We would follow the same increment. This one went 0.2 this way, so let's go another 0.2. Negative 4.4. There we go. This makes a little bit more sense for us. So let's circle the 4.2. Now we have to see, yes, there is a line under here, which means this is included. And is it a mouse or a gator? So it's a mouse looking at the variable, which means we're going to fill in our line going this way, because the mouse means it's smaller. Was there another? Nope. All right, fractions. Fractions are not scary. Please don't freak out. Okay, as long as we follow the same increments, we're going to be just fine. Start with putting the 1/2 right here. Let's go ahead and choose our increments. This one is a little bit easier. Oh, my hair likes to change the color of the board. So this one, the increments are a little easier for us because 1/2 is right in between, well, two integers. We know it's right in between a 0 and a 1. That was easy. Okay, so now let's look at what is looking at our variable. We have a big old gator mouth ready to eat this X value. So the variable is the X right here.
Oh yeah.
So the one that's looking at our variable, it looks like a gator to me. So when I circle this 1/2, first of all, it does need to be filled in. We do have this line under it, which means it is included. Fill that in. And now I know it's a gator looking at that X, so I know gators are bigger than mice, so it's going to go this way. All right. Ooh, this is a fun one. All right, so now we've got a 0. Looking at our X, we're starting at 0. Very good. What is an increment that we can use this time? Let's go a little non-obvious on this one. Let's pick 5. 5? Okay, sure. 5. So what's got to be on the other side then, Mr. Craig? Negative 5, good, because if we went 5 spaces this way, we've got to go 5 spaces that way for our next increment, negative 5. Excellent. So, with the focus on the variable, what is looking at the variable? Well, yes, I agree. That does look like a little mouse to me. My mice are getting stranger and stranger in these drawings, but that is okay. And we know, since a mouse is smaller than a gator, it's going to be smaller than the X. Oh, but I forgot to circle the 0 here. And we do have to include this because once again there is a line under, which means or equal to, the 0 is included. And like I said before, a mouse is smaller, so let's shade this way as my elbow knocks this thing all across the board. All right.
Now we look at this and we're saying, okay, so before we gave you inequalities, now we're giving you the graph. And so when you have a graph and you're trying to write the inequality from the graph, the first thing we have to decide on is what are we going to use as a variable. Now you can use any variable you want, but most of us like to use X. I actually like to use the variable n. I like n because n to me is a number, but you can use any variable. So I'm going to start off my inequalities with a number. And then I go to my graph and I look for where on the graph I have a circle or a filled in circle. And I look at the graph and I say, oh, right here on my graph at 5 I have a circle. So on the other side of my n, I'm going to put a 5. And I always do my variable first, and then the number I'm seeing on the graph. Variable first, and the number I'm seeing. And now I go and say, okay, looking at my graph, found the number. Now I'm looking, is there an arrow going this way, or is there an arrow going that way? And you can see that there's an arrow going to the right. And so, what does to the right mean?
Right is
Greater! Tony the Tiger. Just saying. Tony the Tiger says right is greater, and that means greater is what needs to be looking at my variable. I'm not going to go like this because that's going that way. And some of your teachers have told you, oh, do this. The arrow, the greater than sign goes with the arrow, but that's also wrong. I'm going to look at my variable. I know to the right is greater, so what do I need to have facing my variable? A mouse or a gator? Well, a gator's greater, so I need to have a gator. And then I check really quickly, was that circle filled in? It wasn't, so it's not equal to, so I don't need to put a line. I filled it in, that's it. That's all you do. So let's try one more. Boom. That might be hard to see, so I'm gonna try to change that color. This is a filled in circle here, and this is the arrow going to the left. So again, I always start off with a variable. So I can pick any variable. I'm choosing n again. Oh no, let's just do x. We'll do x this time, why not? We'll do x. And now I look and say, what is the circle filled in or open on? I look and there it is. It's filled in right there at -1. And so again, variable on the left, and then I put my number on the right, so -1, okay? And now I say, okay, which way is the arrow going? Is the arrow going to the right of it, or is the arrow going to the left of it? And the arrow is going to the left, and the left is?
Less.
There you go, left is less. Less than is smaller. So am I gonna have a mouse or a alligator facing towards the variable? Mouse. And so I'm going to put a mouse there, and then I check, is the circle filled in? If the circle is filled in, that means that the answer could be less than -2, but it also could be -1. So I have to put a line on it. So I have x is less than or equal to -1. Okay, let's try one more. I like this one because people get confused with this because they say, wait a second, what's with the increments? What are we going by the increments here? This goes 5, 10, 15. So we just chose to go by increments of 5. Does it matter? No. As long as you pick an increment that is the same amount, it's fine. So again, every time we see an inequality, I need to start off, and I'm creating an inequality that goes with the graph on the number line. I have to pick a letter. I'm going to pick n again. N is my variable. Then I look, where is the circle on? The circle is on the 10. So I'm going to put a 10 on the other side, so I have a space between them. So variable on the left, number on the right. And now I say, which way is the arrow going? Is the arrow going to the right, or is the arrow going to the left? In this case, it's going to the right. And what is the right? The right is greater. And greater means that I have to have either a alligator, because the alligator is greater, facing towards my variable. So I'm going to put an alligator facing towards my variable. And is it filled in? It is filled in, so I know that it has to be greater than or equal to. What that basically is saying, I'm saying n can be any number greater than 10 or equal to 10. All right, last one. Again, we did interesting increments here. I see that I have 1/3. Some people do this kind of stuff. They go 1/3, 1/2, 1/4. And that looks like you're going in the right increment, but is 1/3 smaller than 1/4? No. And is 1/2 smaller than 1/3? No, because it's to the left of it. And are the increments the same amount? The answer is no. That doesn't work. So they went 1/3, and so the easiest thing they could think of was, oh, well, 1/3 plus 1/3 would be 2/3, and 1/3 minus 1/3 would be 0. So the increments are nice here. I like that. Pick a variable. I am going to do x this time. I have the variable x, and then I look at where my circle is, and my circle is at 1/3. That's going to be the right side. I leave a gap again. So variable on the left, number on the right. And now I say, okay, which way is the arrow going? Is the arrow going to the right, or is the arrow going to the left? And I can see that it's going to the left. And the left is less. And less means less than. So we have less than is going to be a mouse. So I have to have a mouse facing towards my variable. So I look at my variable, and I say the mouse has to face it. And now that the mouse is facing, I just check, is it filled in? If it was filled in, I would put a line, because that would mean it was also could be equal to. But since this is not filled in, I'm done. That is my solution. Hopefully that kind of wakes you up to this. There should be some problems underneath this video, and you can go look at it. And the next video we'll talk about solving equations. Thanks a lot.